The problems we face today demand groundbreaking engineering solutions, from tackling potable water scarcity to enhancing energy storage capacity, creating lightweight yet durable structures, to designing accurate drug delivery systems. These problems take us to the details of molecular structures or push us to venture into the realms of space, reaching as far as Mars and beyond. In the quest for solutions, we are constantly seeking materials that can unlock unprecedented improvements and revolutionize the way we address these challenges. Among the contenders, there is one material that stands out: graphene. Graphene has been a buzzword of the engineering world for some time. Let's look at what promise graphene holds and whether any of those promises are becoming a reality. Or is it all just a passing trend? Graphene is no ordinary material. It is a single layer of carbon atoms arranged in a honeycomb-like structure. It possesses extraordinary properties that have scientists and engineers buzzing with excitement. Its unique atomic arrangement grants it a range of exceptional characteristics that makes it a potential game changer across multiple fields. Let's delve into the remarkable world of graphene and uncover why it holds so much promise. First and foremost, its electrical conductivity is unmatched. Graphene can carry electric currents with incredible efficiency, making it an ideal candidate for the next generation of high-speed electronics, flexible displays, and transparent electrodes. Imagine devices that are not only faster and more powerful, but also bendable and transparent, opening up a whole new world of possibilities. But first, what is conductivity and why is it important anyway? In the world of materials, conductivity is like a superpower that some substances possess. It's the ability to easily pass something through them, like an electric current or heat. Imagine it as a pathway that allows electricity or heat to flow smoothly without any roadblocks. Conductivity matters because it plays a crucial role in many aspects of our lives. Let's take electricity, for example. When we use our smartphones, turn on the lights, or charge our laptops, we are relying on materials with good conductivity. These materials allow electricity to flow effortlessly, ensuring that our devices work properly and efficiently. Think of conductivity as the highway for electricity. Just like a well-maintained road allows cars to move quickly and smoothly, good conductivity in materials enables electricity to travel fast and without obstacles. This is why we need materials with high conductivity for things like power cables, electronic circuits, and even the tiniest of wires inside our devices. Conductivity is also important in the realms of heat. When we want to cook our food, keep our homes warm in the winter, or cool down our computers, we rely on materials that can efficiently transfer heat. These materials with good thermal conductivity allow heat to move from one place to another, ensuring proper temperature control. By using materials with high conductivity, we can optimize the flow of electricity and heat, improving efficiency and performance. This is why scientists and engineers are constantly exploring and developing materials like graphene, which is exceptionally conductive. Graphene's ability to conduct electricity and heat with extraordinary efficiency opens up new possibilities for faster electronics, energy-efficient devices, and improved thermal management. Graphene's conductivity is off the charts, making it one of the fastest and most efficient conductors known to humanity, even when compared to materials like copper, which is the most used material for wiring. Graphene's conductivity can be around 70% higher than copper. That's like me competing against Usain Bolt in 100-meter sprint. Graphene's potential doesn't stop at conductivity. It also has the power to transform energy storage as we know it. When we think of energy storage, portable devices such as phones, smartwatches, or laptops are the most obvious things that come to mind. However, batteries get much bigger roles, such as in keeping whole houses powered, like Tesla does with Powerwall, or even whole electrical grids, where Texas is the prime example. 81 Tesla Megapacks were installed there to help stabilize grid during extreme weather events. When it comes to energy storage, the problems engineers are facing have to do with capacity, charge-discharge rates, efficiency, cycle life and durability, cost, safety, and scalability. By utilizing graphene-based materials, we can significantly enhance the capacity and charging speed of batteries. Imagine smartphones that can be charged in minutes, electric vehicles with longer ranges, and energy storage solutions that can revolutionize our grid systems. Graphene's immense potential in energy storage holds the key to a more sustainable and efficient future, if we make it work. When it comes to real-world applications, we have to make the distinction between batteries and supercapacitors. Batteries and supercapacitors are both used to store energy, but they work in different ways and have different strengths. As far as graphene goes, it shows the most promising progress in the supercapacitor area. Batteries are essentially containers filled with chemicals that can produce electricity. When you use a battery, those chemicals react and create a flow of electric current. Batteries are great for storing a lot of energy, like in your phone or a car, so they can last a long time before needing to be recharged. Supercapacitors, on the other hand, are like super-fast energy reservoirs. Instead of using chemicals, they store energy by separating electric charges. It's like having a tank that can quickly fill up with electricity and release it just as fast. Supercapacitors are excellent at delivering quick bursts of energy, but they don't hold as much energy as batteries, so they need to be recharged more often. Researchers at UCLA combined the best of both worlds in a so-called hybrid supercapacitor, storing large amounts of energy, just like a battery, recharging and charging quickly, and lasting more than 10,000 recharge cycles, just like supercapacitors. At just 1/5 of the thickness of paper, it holds double the charge of a typical thin-film lithium battery. All this was made possible thanks to graphene combined with another cheap and available material, manganese dioxide. Quoting the researchers, let's say you wanted to put a small amount of electrical current into an adhesive bandage for drug release or healing assistance technology. The micro supercapacitor is so thin you can put it inside the bandage to supply the current. You could also recharge it within seconds and use it for a very long time. Before we look at how all this is being put to work in real life, there is one last property to mention: graphene's surprising mechanical strength. Graphene's exceptional mechanical strength, combined with its lightweight nature, makes it a dream material for designing structures that are both durable and lightweight. Imagine skyscrapers that can withstand the harshest weather conditions while being significantly lighter, reducing the strain on our environment as less building materials need to be used, while enhancing structural integrity. Or, more down-to-earth application, car components, which are stronger than steel, but as light as carbon fiber. Electric car manufacturers are getting all excited right now. The lighter the car, the longer the maximum journey, and with graphene strength, it could be done without compromising the structural integrity. So far you've heard many compliments about graphene, but what if I told you that it is the strongest material ever discovered? Yes, it is 200 times stronger than steel. Strength in engineering means withstanding a load without deforming or failure. Much like the mythical Greek Achilles, even graphene has its Achilles heel. It is its toughness. Toughness and strength are different properties. While strength is measured by applying a load, toughness is the resistance to tearing. A strong material, like steel, is used to hold an elevator in the air. That's strength, not deforming under load. In contrast, paper would not be very strong material, as you would expect it to rip. Ceramics are strong, but not tough. These materials are described as brittle. They break upon impact. Unfortunately, graphene is brittle, just like ceramics, which means to get the best out of it, it needs to be mixed with another tough material, such as certain plastics, to get the best out of both worlds. So where is graphene now? After thousands and thousands of research papers and patents, are we there yet with commercially viable products? Or are we even able to produce graphene at scale? Fortunately, Graphene in powder form is now manufactured in hundreds of tons globally. So let's check out a few examples of companies in this space. Versarion is a small British company. Although currently far from turning a profit, their product range is expanding. They not only sell single-layer graphene, but also developed a few proprietary graphene-based materials in various forms, such as nanine, a few-layer graphene and graphene platelets, mainly intended for mixtures with plastics to be used in batteries, fuel cells and photovoltaics, as well as conductive inks, concrete and paints for corrosion protection. The application with concrete is perhaps the most interesting one. Versarion partnered with the University of Manchester and a construction firm, Nationwide Engineering, to produce Concretine, a mix of concrete and graphene, resulting in concrete with 30% higher strength. This allowed for the steel reinforcement commonly found in construction to be removed, as well as a removal of 30% of concrete, while keeping all the important properties. This new building material has been used for the first time in a construction project, and more are being worked on. The company combined their newly developed material with 3D printing to offer custom-built concrete structures, and are working with their partners on delivering structures for highway construction projects. Apart from building materials, Versarion aims to bring innovation to the textile industry, as they integrated their technology into sports clothes with the help of a few clothing companies like Bia Brazil or sports company Umbro, or perhaps best known brand Superdry, to produce sportswear with improved thermal properties, which reduce moisture and improve drying rates. You would be right to argue that these are still far from being groundbreaking displays of graphene in action, but let's wait and see. Maybe they will get some concrete results. There is one more company to check, and perhaps they are doing a bit better. NanoExplore. Valued at over 500 million Canadian dollars, Montreal-based NanoExplore is the largest graphene powder and plastics producer in the world, with a capacity of 4,000 metric tons of graphene powder per year. Although they are also yet to turn a profit, their trajectory is much more promising. The company provides graphene-enhanced plastics mainly to the US market, to be used in transportation, wind energy, packaging, electronics and drilling fluids. They expect to bring in 125 million in revenues for 2023. The company plans to go big in batteries, aiming to deliver car battery materials resulting in charging times between 10 to 13 minutes. In comparison, Tesla takes 8 to 12 hours for home chargers and 15 to 25 minutes for superchargers. Graphene undoubtedly holds a lot of promise, but it is no easy feat to turn this promise into a commercially viable reality. The researchers are excited about theoretical possibilities, while companies are worried about having sufficient funding to see their visions turn into tangible, desirable products, delivering hopefully more than just a fractional improvement over existing solutions. Scaling solutions while generating sufficient interest from their potential customers will continue being a challenge for years ahead, although we are seeing the rise of a few success stories all over the world. Just like any technologically demanding innovation, even graphene will have to survive the test of commercial roller coaster before it can find its place among the go-to materials for engineering applications.